Alright, if an interviewer asks you, can you explain what cross-validation is and why it's important? They're testing whether you truly understand model reliability, not just how to split data. So here's how you can answer with impact. Cross-validation is a technique to test how well your model generalizes to unseen data. Instead of relying on one lucky trained test split, it divides your dataset into multiple equal parts, called folds. In each round, the model trains on k-1 folds and validates on the remaining fold. You then rotate this process so every fold takes a turn as the test set. Finally, you aggregate the results from all the rounds to get a stable, trustworthy performance estimate. This rotation ensures your evaluation isn't biased by how you split the data. It shows how the model performs across different subsets, making it far more robust and dependable than a single test run. That's the essence of cross-validation, not just testing your model, but proving it can perform in the real world. Now, if the interviewer follows up with, why does it matter? This is where you connect it to practical value. A single train test split can be misleading. If you get an unbalanced or unlucky split, and the train test played, your accuracy might look great, but your model could fail in production. Cross-validation solves that. It gives a robust and reliable estimate of your model's true performance. Here are the key points you can mention. One more iTunes call. 1. Better use of limited data. Every observation gets used for both training and validation. Nothing goes to waste. 2. Reduces variance. By averaging results across folds, you get a stable, consistent metric. 3. Detects overfitting. If your performance scores vary wildly between folds, that's a clear red flag that your model isn't generalizing well. 4. Enables fair hyperparameter tuning. It allows you to compare different model configurations on an equal footing, instead of overfitting to one dataset split. And if you really want to stand out, mention specific techniques like K-fold, usually 5 or 10 folds, stratified K-fold for imbalance classification problems, or leave one out cross-validation when your dataset is very small. These details show you not only know what cross-validation is, but also how and when to apply it, which is exactly what interviewers look for.